So it's easy to install this demo app, and the whole point is just some demo learning and fun. This is not gonna be a super useful app for other reasons than learning. So the app is very simple, and I just run it. And now if I go to the main page, landing page, here we have cats, dogs, and planes, right? So the colors are slightly different here because I'm using a different library for plotting out the numerical values in each slot in every vectors array, right? I plot them out on a spectrum using this algorithm where blue is cold, the lowest value, and red is high, the highest value. If you look into the blog, I actually link to a text format, if you wonder what this vector really looks like. I mean, it's just a bunch of numbers, right? For every cat image, for every image, you have an array with numbers, and since this Vision transformer model, what I used, it returns 1,000 element vector for each, with embeddings for each photo. You see, here is a photo number 0, right? And now we have an array of 1,000 values, right? Next row has 1,000 values, and so on, right? And that's exactly what this matrix on the screen is, right? It's all of these values actually here, the Vision, this particular model returns values that can be like -7, -50, whatever, plus 30, plus 10. But most of the values are, somewhere, closer to the center of gravity, I guess, 0, right? So if I don't normalize my values, the matrix looks like that, right? And you see there's a lot of red here, a lot of hot numbers, right, in this particular embedding, and you see the value is 8 and so on. So, but all the other little different values in between may, when you visualize them like that, the slight differences may get lost if there are some outlier values that are really big in this particular column, in this particular feature, basically, or embedding for all of, for these cats or for these photos. So that's why I use normalization, so that I pre-compute that for every column, across all 500 cat photos, for every specific feature returned by this model, machine learning model, I will check what is the biggest value and what is the lowest value for that specific feature embedding, slot in the array for all cats, across all cats, right? And I will take the biggest value and smallest value seen across all cats, and I normalize this range from 0 to 1. So it would be nicer for us as humans to see the subtle differences in this matrix, right? Output matrix, or what I've plotted here. So it just makes it a little more interesting, I guess, when you want to learn. And let me make this zoom in as much as I can. You see, indeed, when I find a really blue value, let me just see. Okay, so when you zoom in that much, then it's the mouse is actually slightly off as well, so you have to find it. But you see, there is a cat, slightly grumpy or cat. You see, and that particular dot where my mouse is right now, that guy, right? The value is 0, so that's the coldest temperature, so to speak, in this range. And when I find something like that's pretty red and dark red, you see there is something like 0.9, so that's very close to 1. So 1 is the hottest, 0 is the coldest, and 0.5, half. You see, that's that's like the midpoint, the center of gravity in this visualization.